In this video, I'm going to show you how you can work out the equation of the tangent line of y equals log base 3 of x. So log base 3 of x looks like this. Our job is to work out the equation of this tangent line at this precise point here. Okay, so to work out the equation of the tangent line, you need to know the gradient and the intercept. So to find the gradients, you would need to differentiate this. So from here, it's too hard to differentiate this directly, so let's do it step by step. So from here, exponentiate both sides with base 3. So that's 3 to the power of this and 3 to the power of this. These two, in a way, they cancel each other out, leaving you with x. So the next time you do this, from here, exponentiate both sides with base 3. Just jump to here. Don't worry about this step. Okay, so from here, take the natural log of both sides. So natural log this side, natural log this side. Whenever you log one thing to the power of another thing, the index is able to come down. So that's why you've got y here times this constant, and this is a constant. It's just a number. So from here, differentiate both sides. So when you differentiate y log 3, this is just a constant. It's like me asking you to differentiate 7y. So when you differentiate it, it will be 7, and then because y is a function of x, you need to stick dy by dx in there. This is a constant. This is a constant. This is just a constant. It's just a number. So when you differentiate this, it will just be the number, and then because y is a function of x, you need to stick dy by dx in here. Differentiate this, it will be 1 over x. Now your job is to get dy by dx on its own. So divide both sides by natural log of 3. So that will then give you this. So dy by dx is given by this. So what that means is you now have the ability to work out the gradient anywhere along this curve, but you want it precisely at this point. Well, we need to know the location of this point. Where is this? We need to know the x location of this point here. So to find the x location, let's put 0 into the y, because you know that y is 0 here. This is 1, 2 and 3 and so on. If you want to know the x location here, put 0 into here and work backwards to find x. So when you put 0 into there, 0 equals log base 3 of x. So to get x on its own, exponentiate both sides with base 3. So that will then give you this. Well, 3 to the power of 0 is 1. So this point here is actually 1 across, 0 up. That's the location of this precise point. So we know dy by dx. So this gives us the ability to work out the gradient anywhere along here. We want to know the gradient precisely at this point. Well, at this point x equals 1. So put 1 into here. So that will then give us, so the gradient evaluated at x equals 1 is actually 1 over natural log of 3. So the gradient at this precise point is given by this. So now that we know the gradient at that precise point, we can put it, we can put this into the gradient, into the m here. So this thing here will then become this. So now it's just a matter of working out c. So to work out c, select one point on the line. Well, we know one point. We know this point here. This is 1, 0, 1, 0. So this is your x location. This is your y location. Put this into the y. Put this into the x. That will then take you to here. So now to get c on its own, take away this block from both sides. So c equals negative 1 over 3. So now we can put this back into the c here. So the equation of a straight line is given by this. That's the equation of the tangent line at that precise point. So if you punch this into Desmos, it will then draw your tangent line. Okay.